Welcome to page 19 of Accel Pkt number 4. On this page, we are going to compare unit rates. Our I can statement is, I can compare a graph, a table, and an equation to determine the best unit rate. Question number 3, which is the better buy? Before we jump in, let's do some information dumping on the top of our page. We know that when we write an equation for a proportional relationship, we use the format k times x equals y. Also, when we're calculating the k rate, we always take a y value and set it up in a ratio with its x value. The constant of proportionality is calculated by taking y divided by x. And finally, when looking for a unit rate as an ordered pair, we know that it is 1, k. The constant of proportionality is your y value. Let's dig in and find the unit rate for each problem. We have gas station 1, gas station 2, and gas station 3. For gas station number 1, we can see we've been given an equation for a proportional relationship. K times x equals y. Well, we know our k rate is 2.6, our constant of proportionality. And we know that we can take that amount and put it over 1. 2.6 over 1. Now it's written as a ratio. The y value is 2.6 and our x value is 1. But what do those numbers represent? If you look at the table, we know that y represents cost. So our top amount, we're going to write in dollars. And x, well, x represents our gallons of gas. So as a unit rate, gas station number 1 charges $2.60 per 1 gallon. Now let's move to the table and find the unit rate for the table. We know in order to calculate the k rate, the constant of proportionality, we're going to take cost and put it over gallons. Y over x. So let's take a specific example. $4.80 for 2 gallons. Now this isn't a unit rate because we know for a unit rate we want the cost per gallon. So take this ratio and divide. 480 divided by 2. If you divide or reduce, you get $2.40 per 1 gallon of gasoline. That's your unit rate. And if you compare that to gas station number 1, clearly, right now, gas station number 2 at $2.40 per 1 gallon is the cheaper gas. But in order to make that comparison, we had to get unit rates in each case. Now let's check gas station number 3. Whenever you're given a graph, we know that making a t-table next to that graph can be a very handy way to analyze the information on the graph. X still represents gallons, and Y, like the previous gas station, the Y value, of course, represents cost in dollars. Now, we need to grab a couple readable points off this graph. We see that X, of course, is your gallons, and Y is your cost in dollars. As we look at the graph we've been given, it might be difficult to tell what value is associated with an X of 1. So my first good readable point might be the next point. 2 gallons of gas costs $5. And another good readable point might be this one. 4 gallons of gas costs $10. Well, we need to calculate the K rate. Let's take, for one last time, Y over X, or in this case, $5 per 2 gallons of gas. Now that's not a unit rate. Remember, for our unit rate, of course, we want it per 1 gallon of gas. Well, if you reduce, or you could punch this into a calculator and take $5 divided by 2, you get $2.50 per 1 gallon. So, all things equal, we can say gas station number 2 has the better buy. Gas station number 1 has the most expensive gas of all 3. So on the line, we will write station number 2. Take a moment and explain your work. You want to mention that you found the unit rate for each gas station, and gas station number 2 has the unit rate with the cheapest gas. Pause your video and write an explanation, then compare it to the video. Please pause your video now. An explanation might look something like this. Station 2 is the better buy at $2.40 per 1 gallon. Find the unit rate for each station and compare the unit rates. Let's move on to the next problem. The next problem is completed almost the same way as the gas station problem. You're going to pause your video and try this one on your own. But first, let's read together. Which is the better buy? Apple stand number 1, stand 2, or stand 3? For stand number 1, you're going to write a unit rate. When you know your K rate is 3.7, and we know we need to write it as Y, which is cost, over X, which is the number of pounds, you know that the unit rate is $3.70 per 1 pound. That's easy. You're just taking your K rate and writing it as a ratio. But for stand 2 and stand 3, there's some work to be done. For stand 2, you're going to find the unit rate by putting Y over X and reducing. For stand number 3, you're going to make a T table with Y still being the cost and X still representing the different amounts of apples in pounds. But you're going to grab a couple of good readable points off the graph, like 2 pounds for $9 and maybe 4 pounds for $18. And again, once you have this in table form, you're going to figure out your unit rate by taking Y over X, dollars over pounds. When you get all the unit rates, compare them. Which is the better buy? But you need to get all of them in unit rate form. Pause the video right now. Calculate the unit rate for number 2 and number 3. Answer the question and then write a complete explanation, such as above. When you're ready, turn the video on and check your work. Pause your video right now. Let's check your work. For stand number 1, you should have gotten $3.70 per 1 pound. For stand number 2, $3.90 per 1 pound. And for stand number 3, a whopping $4.50 per 1 pound. Clearly, stand number 1 has the better buy. So you should have written stand number 1. The written explanation should have looked something like this. Stand 1 is the better buy at $3.70 per 1 pound. Find the unit rate for each stand and compare the unit rates. This concludes page 19.